Hi, I'm Mark Needham with StarTree, and in this video we're going to learn how to work with geospatial data in Apache Pinot. So what we've got here is a data generator that's going to create some JSON messages that contain a timestamp, an ID, a count, and then some various geospatial objects. We're going to have a multi-polygon, a polygon, and a point, all in Wicket format. And so we can call this command, and we'll just grab the first record that it emits, and we'll pipe that into JQ so we get a bit more of a prettified version of this JSON object. And so you can see here we've got a polygon string, so it's got polygon and then it's got a bunch of coordinates. We've got multi-polygon, which contains multiple of those, and then we've got a point as well. Now what we're going to do is we're going to create a Kafka topic. So we're going to call it events. It's going to have 5 partitions, and then we'll create it and give it a couple of seconds, and there we go. It says we've created the event topic. Now we're going to call the datagen.py file, and we're going to pipe the output of that into JQ so that it can construct a key payload format that Kafka expects. And then finally, we'll pipe that through the KCAT tool in the producer mode, passing in the broker and the name of the topic. And we'll sort of leave that running on that tab there, putting data into Kafka. Now we need to have a look at how we're going to get this data into Apache Pinot. So this is the schema that we're going to be using. So notice like we've got the count, we've got the UID, and then each of our geospatial fields, so polygon, multi-polygon, and point, all must have the data type bytes because we're going to be storing a serialized version of each of these things. And then we've got, at the end, we've got the timestamp as well. Now let's have a look at our table configs. Remember, the name of the table and the name of the schema need to be the same. So we've got events. If we look down a little bit more, we've got the Kafka config with the broker and the name of the topic. And then if we come all the way to the end, this is the most important part of the file, we've got some transform configs. And what these functions are doing are taking those Wicket representations, so i.e. polygon string, multi-polygon string, and point string, they're converting them into a geospatial type using the stgeom from text, and then we're also making sure they're in the geography type because that's required by some functions that we're going to use later on in the video. And so those will be run as the data is sort of coming from Kafka into Pinot. Now we'll add our table, so we're going to call the add table command. We'll pass in the schema file, the table config file, the controller host as well, and then let's run that command and give it a few seconds, and we've got our events table. Next, we're going to create another table, so pretty much exactly the same, but it's going to have a geospatial index. Now, geoindexing in Pinot is based on Uber's H3 library, which is a hexagon-based hierarchical gridding. And effectively, it means that each point that we index gets mapped to a hexagon that has an ID. And its neighbors in H3 can be approximated by a ring of those hexagons. So for example, in this diagram of San Francisco, the red hexagons are a distance of 1 from the central hexagon, and then the ones one more out from those red ones would be at a distance of 2. So let's have a look at the table config for it, which has a geo index defined. And so you can see it's under field config list. And so we need to specify what's the name of the column it's going to apply to. So it's point, encoding type raw, and then index type needs to be H3. And then you can specify a resolution, which basically defines like how big are those hexagons going to be. So we'll just go for 5. That seems a reasonably in the middle value. And so if we scroll down, we can see the transform configs, and those are exactly the same as what we saw with the events table. Now let's create this new table. So remember, this is the events geo table. So we need to also have a schema with called events geo. It's exactly the same as the other one, just has a different name. And then again, we're going to execute this command, and we'll give it a few seconds, and we've now got 2 tables. Now let's come over to the Pinot UI, and you can see we've got 2 of our tables. We've got the events and we've got events geo. Let's write a simple query. Just select star from events, and you can see we've got a bunch of events in there. So far, so good. Let's write a query to see whether or not we've got any situations where the point in a row or in a record or even in a document exists inside the polygon. So we're going to write a query, and we'll return the st_within, and we'll pass in the point and the polygon. We'll also convert the polygon and the multi-polygon and the point into a text format, and then we'll put in a where clause that checks is the point inside the polygon. And you can see we get back quite a few that are there, and we can also see the textual representation of the polygon as well. Now let's have a look at something where we will eventually be able to use our index. So we can write this query here that basically checks, show me the points which are within 50,000 kilometers of a particular location in San Francisco. And so we can run that, and you can see it takes about just over 60 milliseconds on the events table, and we get back a bunch of records. Now, how about if we do the same thing on the events geo table? And so this is where we would expect the index to be used. So let's run that query. And you can see now it's only taking 9 milliseconds. And granted, it's not very many documents, right? It's only 600,000 documents, but we've already got quite a big speed improvement. So we've gone from 60 odd milliseconds down to 9. So let's just quickly run through what was going on with that events geo query. So what happened is Pinot first worked out the hexagon that our point belonged to, the San Francisco one, which that was a location in San Francisco, so it's the hexagon for there. Then it converted the distance, so 50 kilometers, into a number of rings, and it found the hexagons that completely or partially fitted inside that radius. And finally, it worked out, okay, which documents in Pinot map with those hexagons. And if it was one of the hexagons that fully fit, then we can just say, okay, well, we know everything in there is good, so we can return that. And if it partially fits, so I use a bit of an overlap, then we need to apply our distance predicate to check, like, are they actually fitting within the distance? And so that is basically how it works. That's the end of this video, in which we've learned how to work with geospatial data in Apache Pinot. Give it a try and let us know how you get on. And I look forward to seeing you in the next video.